All right, so welcome to DevOps Live. We are joined here tonight by Jim and Chris. They have done some pretty cool pipeline work with Terraform and Packer. They're going to show you. For you raise hand, guys, it's a repeat. Yeah, so a couple of announcements. Make sure you guys are keeping an eye on DevOpsDays.org. We have Dallas 2017. It's going to be August 29th and 30th. So it's nowhere near HashiConf, right? Different month altogether. So keep checking on that. There's plenty of volunteer opportunities. If you guys want to be involved in that, let us know. Also, devops-engineers.slack.com is a really fun Slack channel. A bunch of great guys in there. If you're a Puppet guy, there's a Puppet channel. If you're a Chef guy, there's a Chef channel. Pretty much anything you could get into. I think there's even a firearms channel if that's the way you roll. So, yeah.
It is.
So without further ado, I'm going to introduce Chris Fromm, and he's going to walk us through some Terraform stuff that we've done, or that he's done.
Welcome. I'll start off by telling you I am not a salesman, presenter. If I was, I'd probably be like in technical pre-sales, making all kinds of money at Palo Alto or something. Instead, I'm a nerd. So what I intend to show you is essentially nerd stuff. So if the presentation doesn't work, so to speak. All right. I'm not on this slide anymore. All right, so this particular project, it really came about because the place that we're currently working had essentially a fairly long history of the problems that truthfully all of us have seen consistently over and over and over again, which is it worked on QA, right? Or it works on my machine, or errors that occur only in production. And really, the source of that stuff is obvious. It's just that those environments aren't the same. We really kind of went after the holy grail, as I call it, of DevOps, which is infrastructure as code and complete infrastructure as code, and immutability, immutable servers that don't change from A all the way to prod. So you essentially strike an AMI or a container. AMI container that you use all the way through. If there comes a need for a change in that AMI or container, it goes all the way back to QA. And the operating system and the app all at the same time. So it's a little stuff about us. I've been in technology for 24 years, held every position from engineer to VP. I'm a tech ops guy by career. I've kind of turned to DevOps now really because it's incredible the power of sort of creating the environments and servers and load balancers and networks and things that I've spent weeks, months doing in seconds. I enjoy candlelit dinners and long walks on the beach. And if you believe that, then no. And then that's my LinkedIn. Jim has been in IT for 20 years. He comes more from the build management, more dev side, kind of like kidding. And he has a farm and raises chickens and actually sells eggs at work. First carton's free, then you have to pay. Yeah, and there's his LinkedIn too. So anyway, we're talking about infrastructure as code. And the things that I've found are just really kind of irreplaceable and so important in doing this is essentially you create repeatable processes. Server that is just like the other server, you just run the process again with a different name. Obviously sort of the same reusable effort. You write that structure once, you write that network or security group, for example, you've done it once. Now you can take that code and splat it 20 times and create 20 security groups. Versioning and reviewability out of your changes. So in a tech ops world, when you have a system engineer and he goes in and he changes, you know, the IP address and he changes the subnet mask on a server, or he does some update or something, yeah, you might have like the event log. Look for stuff like that in the event log, right? So in this case, every change that's made through infrastructure as code is essentially documented by Git. I mean, it's in your repo. Figure out why that server or that infrastructure started breaking, you just go back and you look at commit history, just like you do in code. The whole app stack world. You can't make manual mistakes. I mean, essentially, what was in the code is what comes out the top. There's no oops. Again, I typed something bad, or I have that also. No typos. Can't fat finger subnet mask. I don't know how many times, and this has happened to me. A production problem, you know, in production, and it just literally turns out that an engineer, you know, a large subnet mask or a restrictive subnet mask or something that just wasn't appropriate. And then order of operations, it's static. So, I mean, it shouldn't happen this way, but it does, right? A single engineer, and he builds a server manually. He follows exactly the same steps, but in a different order. The server turns out different. It does, right? And so when it's in the code, it's going to execute the same way every time. It's repeatable and reproducible. Well, you know, let's say our particular company or particular projects don't get all the way to something like immutability or full environment or infrastructure as code, right? Some of the pieces are so important. Like in our own project, as we started to use these provisioning management things like Terraform or CloudFormation, we found that even if it wasn't for ADLC, even if we weren't deploying code, there are huge boons that you can gain. And like the biggest one I know of is security groups. I assume everybody uses AWS or has played with AWS. So one of the biggest problems with security groups is that you cannot document each line. Port 6789 was for this reason, or that port, it was for this reason. You can't. And then so when you're auditing those, you're auditing your ports, there's no documentation as to why that was allowed through. And another document, but with a provisioning management like CloudFormation or Terraform, this could actually be code even if nothing else was. And so when you needed to make a change, you can document just like you can in code. You know, you put a comment symbol, you put, hey, this line or this port is for this reason, or it's temporary, or whatever you want to. You could put who changed it. And then run that Terraform or that CloudFormation, and all it's doing is creating those security groups. It's pretty awesome. I mean, if I was to do nothing else, I would code my security groups. Immutable servers. So it's a natural progression of infrastructure as code, because if you get all of your infrastructure as code, immutable. All that really means is that all your changes are made through a build process. You know, all of us, I'd assume, going back many years, you have a server and you have an application. Well, the old way was server, it's a long use server, and when I need to put new code on it, I deploy new code. And kind of like the conversation we had a minute ago, is when those environments, or when that long-standing server sits there for months, even weeks, it becomes, and Linux is better than Windows, but the longer the server runs, there's sort of this corollary effect. Perform less, right? Why does it become slower? I mean, it's because of cache files, it's because of paging files, it's because of memory. If you've got infrastructure as code and you're deploying a new server every time you build, fresh server every time, and it's an identical server every time. From QA to production, let's pretend you have an e-commerce application, right? 1.2, you strike a new server, you put 1.2 on it, you deploy it, and it's the same server in every place, in QA, in UAT, in perf, and prod, same server. So you get your server state locked in the app build. So I talked about that. After release candidate, I kind of talked about that too. Literally no chance for an environmental difference. We sent a new server out every time from QA to prod. And then the last one is kind of like the mistake that we've all made, which is we introduce environments. And it's usually the QA means that the environments were different, the servers were different sizes, or there's an environmental translation. But this rogue insertion, this is 3 weeks ago, I was troubleshooting a SQL problem, and I put Wireshark or some other profiling tool on a server, and it sat there and has run for 6 weeks or 3 weeks or however how long. It's using 600 gig of memory. It's got a temporary file, God knows. I opened or ran an application, and with this, there's no reason an admin or an engineer would ever need to log into a server because you make all your changes in code and redeploy. Yep.
How do you link that the recent issue with the AWS insertion or putting some number? It was an outage, right? AWS.
The outage?
The S3 outage or the Ubuntu outage?
S3.
Yeah.
That's not really relevant
Yeah.
to what he's presenting here. He's
No.
talking about.
It's relevant back to the no typos, because that whole S3 outage was a result of a manual operation where somebody did a typo. If you were using an automated tool, that
That's
wouldn't
correct.
happen.
Outage actually, and it took down literally the world. Actually, it didn't take down everybody, because if your infrastructure didn't depend on S3, it didn't hurt you. So it was really funny because everyone was freaking out. My AWS is down, and mine was fine. Anyway, so this is actually what the pipeline looks like. It uses, let's see, 4 things. It uses Jenkins, build and compile, and also orchestration. So we're using Jenkins to make commands to Packer and a Terraform, and it uses Packer and Terraform, and then console as a key value store. Go through the
So basically, like probably most organizations, developers are committing their changes to some Git repository. Upon that commit for say a release, we'll pull from Git. We're a Microsoft Windows shop, so we'll do an MS build, and then part of this creates a application. What I'm doing is I'm taking that application, I'm using Octopack because it's very convenient, and it builds a new Git package for that. So I ship that package off to Artifactory there. As that is, it basically is going to run a Packer command that will basically go and take a base image, Windows base image that has all of our supporting software, our log aggregation tools, our monitoring stuff, that kind of thing, already pre-installed on it. And then it will lay the application on top of that and create a new AMI from that gold image. And then basically it will store that AMI out into Amazon's repository. We're tagging those, we're naming those, and we're tagging those in a way that we can easily retrieve them with Terraform, the app version. So we always know what application and what version of that app is installed on that AMI. And what this gives us is basically a library of machine images that we can deploy into our environment. If we need to change a version or we need to revert back to a version, we can update our Terraform code and rerun that, reapply that, and we can that had some error on them or some misconfiguration and go back to a previous version.
Are you also covering what is Packer and what is Terraform?
So yeah, I can cover that. So Packer is a tool that from HashiCorp that basically will take build an image for you, a Amazon machine image, a Vagrant file, Docker files, and basically it will build you an image that you can use either in Azure, Amazon, whatever. It's basically a script that runs. Once that image comes up, it'll run a bunch of scripts, change configurations, set up users, whatever you need it to do. We're using mostly PowerShell scripts because we're a Windows environment, but you can write Bash scripts, Python scripts, whatever. And then it basically takes a snapshot of that image, sysprep on it so that we can redeploy that, and then it stores it back out into Amazon's AMI libraries. So it's basically taking image, applying the changes that we need, the software that we need, whatever we need, and then taking that image and putting it back out there so that we can use it in other applications. Terraform is the tool that we're using. It's on another HashiCorp tool that will actually build out the environments based on a script. So infrastructure as code is basically what Chris was talking about. This is the Terraform piece that does the infrastructure as code. Up above Terraform basically builds the files and the images and the stuff that Terraform is going to need to deploy that environment.
Is the one that converts into the real deployable.
Yeah, and we'll demonstrate that here in a little bit. So Terraform basically uses a JSON type syntax to configurations, and you can put things in like, I want this AMI, this specific AMI version, and it will go and I want an EC2 instance of T2 large or whatever, and it will build that instance out in whatever environment that you have. So when we get down here to the bottom, Terraform is actually, like I said, is actually taking all of these AMIs or whatever, and it is executing these scripts to actually implement those environments. So we can go from having no PC to building out the entire VPC with DHCP options. What subnets we want to use, what region we want it to be in. What kind of servers we want to be in there, how many of them, all that stuff.
The same thing with containers?
Terraform
against containers.
We could actually do the same thing with containers, but because we're a Windows shop, it doesn't really make a lot of sense for us right now, because it's kind of a fairly new technology, and Windows containers, quite frankly, are like 6 gigs. So
we will very soon. So yeah. If anybody's familiar with sort of Windows C# .NET development, it's been locked in Windows now for many years. Been locked in Windows literally its whole life. But .NET Core 1.0 essentially came out about 3 months ago. .NET for really any environment for Linux. So it's .NET that can run and our initial testings are that it's capable. The only reason we haven't switched to it of module support. So like things that we might use inside of C#, like log4net is a good example. They just don't have that module ready for .NET Core. But as soon as the modules that we use reach maturity, we're wrapping this process and going with containers.
Yeah. So, I guess any other questions about kind of this pipeline process? All of this is basically run through Jenkins, and we use Jenkins in much the same way as everything is stored in a repo. All the code that it runs as part of the pipeline is stored in our repos, so we can version those things. And I think that's pretty much it.
So kind of going back to your question about, what is Packer, what is Terraform? So these components, everybody knows what Jenkins is. Jenkins builds stuff, right? Packer, really, it's not really complicated. All it really does is makes images. The same process that we did like 10 years ago, where we launched a desktop and then we took out Norton Ghost, and we use Norton Ghost to create a ghost image or a GHO file, right? And then we stored that on somewhere, and then if we ever needed to use it again, we booted a laptop with a ghost disk. It's essentially the same thing, right? Everyone's familiar with, AWS has AMIs. What's it called? OVAs? No. Yeah, OVS. Google Computing has one. And basically all Packer is sort of a platform agnostic images. That's really all it does. It can do it for VMware. It can do it for Google Computing Cloud. It can do it on Azure, and it can definitely do it on AWS. Really sort of the same thing. All Terraform really does is AWS API commands or Google Compute API commands. So, I mean, do anything, all that. You could take, for instance, PowerShell and the PowerShell, module for AWS, write PowerShell commands to do exactly the same thing. Using something like Terraform or CloudFormation is it remembers the state. So whereas if you had scripts, you just run them. Remembers what you ran, which one of those things is still running, which ones were deleted, and when you run it again, it'll recreate only the ones that failed. So it won't create the one that's the missing. Does that make sense? So I kind of have an example here.
I guess couldn't you do the same thing with PowerShell desired state configuration?
You kind of could, but good luck writing it. I mean, I'm certainly not a developer. That'd be a joke. So actually, this is an example of Terraform. Packer and Terraform actually are a coding language. For instance, if you're familiar with Chef, right, and I have to learn Ruby too, right? Terraform, it's really a configuration markup language, if anything, right? It's all JSON, JSON related, so to speak. JSON structured, and all Terraform does is it follows this JSON essentially to the letter. Now there are some kind of ways to program against it, the way you would typically think. Again, it's not using Python or Ruby or Perl to go out and change. There's tricks. So like this notation down here at the bottom, you see the brackets and the $sign or the curly braces and the $sign. Another object that's not visible on this page. So is actually an object like if you created a security group. In this Terraform right here, all this does is create an instance. Actually, it creates 3 of them. Instance, it's going to create 3 instances of T1 micros, and it's going to tag them hello world, this security group. And so in this sort of variable notation, there are kind of some ways sort of program in Terraform. An example, I have count equal to 3 right here. Instead of being a sort of a hard value to a security group, something that would change each time those 3, then you would get 3 servers that have a completely different security group. And there's some really tricky ways on how to completely different servers out of the same block of code, but it's really creating some very creative interpolations. Not let's see what else. Oh no, wrong side. So I kind of just want to show it to you. Is that okay?
Yeah.
So Terraform is essentially it's a course program. You could go get it today. And typically you would execute the commands on command line. But since we're using Jenkins for orchestration and we've tied these things all together, but really Jenkins is just executing command line. In its execution, it's just doing command line statements. But things here in our demo tab on Jenkins, we've got 2 Jenkins jobs. One is it's called Probo. That's our word for test. That's an environment add by branch and Terraform application. So I'm going to click on environment add by branch, and I'm going to say I want to build with parameters. I get to put, and Jim, when I type something wrong, tell me. So
behind the scenes, so you guys, if you're familiar with Jenkins, you know about these build parameters. Behind the scenes, it's not a freestyle, it's actually a pipeline project. So once he hits build, it is actually, it's going to pull down the code from the repo and the script that it's basically going to run. I have a job or a Jenkins jobs repo version the jobs as well. And within that job, it's going to pull down the Terraform code and actually execute the Terraform code. But you was open there. I was going to say you could
have what repos open?
you have the repos downloaded, the Jenkins jobs.
Yeah. The code, you mean?
Yeah, for Jenkins jobs.
Yeah.
So I can show that to you.
Yeah, we can do that.
If we want to, if we have time later, I can.
You said that you can or do parameterize which MI images uses. It's not a parameter in the pipeline.
That's correct.
So what does it do latest?
So this one right here is only going to build a what we call an environment, which is going to be a VPC that has no, it has a couple of EC2 instances for our Bastion host and things like that. It doesn't have any applications in the environment. So if you wanted to just build a shell of QA in here.
That's what this job does. So in our sort of typical SDLC build cycle, we likely wouldn't call this job. Probably deploying to QA or UAT or perf, in which case those environments were already created. But just to sort of show infrastructure as code, probably the coolest one. So I have told it I want a perf environment. I want it to be a CIDR of 172.28.0.0. I told it I want it to be in US West 1, which is Northern California, to run the demo branch of my Terraform code. So build, so I'll try it, right?
Let me ask another question.
Shoot.
You're building a shell of an environment. I understand that.
Data center.
Yeah, a shell of a data center.
Oh,
I don't know what that means.
Hang on a second. I forgot something. I got to show you the. Oh, come on. Yeah, before you see anything, I got to show you there's nothing under my sleeves, right? So there's nothing there, right? Okay. Go ahead.
So my question is, why, philosophically, why did you build a data center script, a Terraform script, whatever you want to call it, and then another one that stands up, if you will, the environment?
That's a.
There's a philosophy.
Yeah, there is a philosophy behind it, right? So, okay, so you see, it's making security groups, it's making auto scaling groups, it's making NAT instances and Bastion hosts and VPNs. To your question, right? Sort of a Terraform best practice, and the reason is that when you have structure of Terraform, right, it's going to create a state file, right, or well, still a state file, even remote, right? It's going to create a state file. That's how it remembers what it did last time and what it needs to do next. And we could conceivably have a single all of these things.
VPC level.
Right, and then at the VPC level, it could do all of the applications. It would almost be impressive because it would do so many things. You're sort of locking your infrastructure into this one state file. That state file gets lost or that state file gets corrupted. Structure. Oh, it does. It absolutely does. Breaking the applications up into different builds, right?
Even pieces.
Yeah, so like each one of our microservices is essentially run through as an application, has its own state file. So not only do they have their own state file, but then there's no chance of cross-pollination. I don't know why, but it recreated your servers, your services instances when I ran my service, right? It's really logical separation. It's powerful. So anyway, this has finished.
Well, when you're cutting over from you don't want to cut over from one VPC to the other. You want to cut over from one set of application, right? Are you building the entire VPC every time?
No.
Right.
Yeah.
But you are building brand new servers.
Correct. Yeah. We needed the VPC and the app to be separate, not only for the reasons I said just now, right? Right. But hang on. Largely because of the thing I talked about just a minute ago, right? QA, for example, we're going to need it all the time, right? There's no need to keep recreating QA, right? It's mold of the traditional, which is there. But the advantage of having this script is when somebody says, ooh, we need a proof of concept environment, or we need a demo environment, or the CEO wants to show something cool to an investor, we don't have to open up to the outside world, or we don't have to, do some sort of jerry rigging or throw up new servers. We just essentially create an instantiated environment, call it whatever we want to. Called CEO's mess, right? And launch whatever applications we want to it. And then when we're done, destroy all of it.
You could actually build an entire environment and for QA, do all your QA testing and then destroy it when you're done.
Mm-hmm.
Our particular environment, we have a lot of ecosystems that depend on each other. Like one run without the services from this other one over here.
So
So
you say ecosystem.
I'm saying like we
data center.
So no, I'm talking like a application has these maybe three parts to it: an API, a web, and then maybe an admin piece of it. Well, those three components can't run without the one component from another stack. We kind of tossed it around. We said, you know what? Say they're semi-permanent. We probably wouldn't destroy it unless we mucked up the entire environment and we had to start over. But for production, it will probably always be there. For QA, it'll probably mostly always be there. But you can basically take pieces in and out of it and change versions.
What you said there then is that your architecture, your software architecture is loosely coupled from the cloud proper.
Yeah, and we're talking about legacy systems too that were built in a data center, and we're trying to move them to microservices. So they don't all fit nicely into this. So we have to, adapt to that. But one of the things I wanted to point out, I don't know if Chris, you were going to point out, but if you can see there in the apply complete, how many resources were added.
72. I was going to ask you if the time's in here somewhere.
Yeah, if you go back up to the top to the job, I'm not going all the way up.
Back to the job.
You'll see here it took
1 minute and 24 seconds.
24 seconds to actually apply.
24 seconds. And now I want to talk to you about kind of what it did. Terraform just provisioned a VPC. It created a DMZ subnet, web front-end subnet. It created a back-end subnet, internet gateway for that VPC, routing tables for all three subnets, created 2 NAT servers, 2 load balancing instances for our DNS console environment, created 3 DNS console servers, created a Bastion host, a Cisco cloud router, and configured a VPN that connected back to our corporate office for Active Directory, for everything above it. So in 1 minute and 24 seconds.
So you mentioned you're using console there. Is that for just your monitoring?
We're using console in actually a couple ways. So mentioned console as part of the out pipeline. Console in the out pipeline is a key value store. From environment to application and from Jenkins to both jobs, it's kind of how we're
Moving state.
It's moving variables around. So one of the challenges, going back to Alan's question of why not kind of do it in one monster, right, is all those variables all the way down, right? And even in the broke up fashion that we did it, that becomes pretty painful, passing these variables around. And so we inserted console a little bit as sort of a coding shortcut so that from in the application, I didn't have to somehow reference environment because, when you build servers, they need to know what subnets they're in and all that kind of thing. Show these to you just so that you know I'm not lying. So this was empty. Now it's got, what, about 10, 11 instances. And so there's a VPN server connected to our corporate office, DNS load balancer, the console servers, and a Bastion host. So if we look at security groups, these are not all ones. So it created all of those. There's a load balancer in there. Oh yeah, there is. Oh no, there's environment also. But it did essentially. I got into this just because of the sheer amazement in it all. So the stuff that it just did, in my mind, because I'm old, right? It just wired a switch. It just racked and configured a firewall. Configured, 10 servers? I mean, hell, it built the cabinet, the air conditioning, the electricity. In my mind, it did all of that because that used to take us weeks, right? That happened in a minute, 24 seconds is why I'm doing this, right? Okay, so anyway, let's launch an application now. So we've got a separate Jenkins job for that. That's this one. And anybody familiar with Jenkins? The reason this is actually our build environment for when we're developing Terraform and Packers, so that's why there's all those failures. In our real environment, you don't see all those. Okay, so I'm going to tell it my environment is perf. Demo application. I want version 1 of the application. Which branch I want Terraform to run from. Code. And then I'm going to tell it to apply. But first,
talk about plan and apply and the differences.
Oh, that's a good idea. Hang on. It's not quite as fast over an air cart. No. So he made a good shout out, which is Terraform has 2 commands. Doesn't it?
Yeah, well.
I think. Well, anyway. Yeah, plan is it'll tell you what it's going to do, right? And plan is actually the easiest way to not get like surprised. And if you have told it the wrong environment or given it the wrong name, and it comes up and says, "I'm going to delete everything you have," that's not what I wanted to do, right? And then apply is do it, right?
So plan is really useful. So in our application space where we want to upgrade an application to a new version, you should run plan against it initially to see, like, is it only going to change these EC2 instances, like destroy these and replace them with new ones. Plan would be where you would see, like, oh, it's just running the whole environment. We did something wrong.
Yeah. Right? I'm going to say I use it less than I should. It's kind of like I don't always test my code, but when I do it on production. I'm kidding. Okay, so command that you just saw me run in PowerShell was actually to populate console values that the application needs. We sort of have not yet. This is sort of the second phase of our project, which is
It's a little gap.
like a solution file or config or is in the project instead of this manual step. But
Can I ask you a question?
yeah, shoot.
I know that there are various people at different levels of automation in their respective area. So obviously you did a lot of investment in researching and getting this operational, right? So how long did it take for you to develop this pipeline?
Since September.
September of last year.
6 months.
It started at the end of September.
Yeah.
So
6 months.
So could you also some kind of a brief on your journey on what all technologies you zeroed down?
Yeah, absolutely. Let me run the application.
After this,
I
don't know.
Sure.
Yeah. All right, check my work again. Perfect.
Yep, you're good.
All right, so I'm going to run. And again, we saw we only had those 11. It's going to do quite a bit more. Yeah. No, there it is. All right, so now we see Terraform's doing its thing. And we can already probably see, for instance, instances getting created. There's one that's pending. It's booting right now. There's going to be probably, what, maybe 30 more. So I'll just come and jump to what it's going to do. Terraform going to do. So in this particular application, it calls for an auto-scaling group. So that auto-scaling group is going to be configured with a 1 to 10. So it's going to create 10 servers. It creates the auto-scaling policies to scale up and scale down. The ALB for the application. It updates DNS or Route 53 with the A record for the new load balancer. It creates 4 Couchbase servers, bootstraps the Couchbase servers, configures a bucket. It registers both the application and console and Couchbase into console. This is sort of the other thing I mentioned that console is being used for. So in the actual environment that I'm provisioning, we are using console for service discovery. So essentially what it's doing is it's spinning up all these applications and registering console. Servers, it created 3 Elasticsearch servers and then the security groups for everything above. And so it's running longer.
So is picking up the that you created using Chef's PowerShell?
So what this would do, and that's not actually what this is doing because it would take longer. So today, right, when we essentially run that, it bakes a new image of our application in Packer, and it passes it off to Terraform. And so the auto-scaling group that's being created, yeah, it's already done. So the auto-scaling group that got created in here is spinning up the AMI that Packer made. Yeah. Now the Couchbase instances, the Elasticsearch instances, and SQL instances, we have manual Packer builds that those run because we don't. Those aren't automated builds. For Couchbase, we're using that gold image for Couchbase until our Couchbase engineer says, "I want a new image of Couchbase."
So flip over to the AMIs for a second, and you can show them. Did the and then change that. That's fine. So you can expand that name out there, and you can see the you'll see a change in version numbers in the.
I can't get to move.
So you'll see the top 2 up there are like our Windows-based images. One's got IIS already installed. One's just a plain old Windows image. And then that temp demo is the AMI that Chris just called for the demo application, which is a very simple. The rest of them are actually the Couchbase you can see at the bottom. Different images based on Packer builds that the application builds that I'm doing with Jenkins. This is basically the library that I was talking about of AMIs that are available.
So clicking back to instances, there's a lot more now. There's a bunch of instances still booting. But we'll go look at Terraform. So that created.
Is your Jenkins server also running on AWS?
Yes.
It is. It is running on an EC2 instance. We've talked about doing, immutability on our Jenkins servers. For our Linux, anything that can run on Linux, like our Packer builds all run on Linux, our Terraform runs on Linux. We could absolutely do that. For Windows, it doesn't make a lot of sense because of the amount of time it takes for a Windows server to actually come up and be ready for, for it to do stuff. Talks in a matter of minutes. Windows takes significantly longer. So, We have one window, right now we have one Windows build server that's handling all of our MS builds on Linux boxes.
Linux boxes, not on EC2, right?
No,
They are.
yeah,
on
EC2.
Oh,
Linux,
okay.
But you could spin them up in Docker for if you had a build. If you could set this up where Jenkins would build a Docker Jenkins build agent, archive the artifacts, and then destroy the Docker container.
Actually, we were going to. It
We
just,
will probably do that at
Yeah.
some point. It just doesn't make a lot of sense right now for us because we're predominantly doing Windows builds.
so the application built in 2 minutes and 11 seconds. Let's go look. I already kind of went through what it was going to do, but let's just kind of look at the list of EC2 instances here. I'll just tell it. So there you see we have our 10 instances of the app server. That's an auto-scaling group. Space servers. There's our 3 Elasticsearch servers.
Will you click on one of them and show the tags just so they can see that the
Oh, absolutely. That's another thing really, really nice about using CloudFormation or Terraform is there's 2 things that get unruly and out of hand very fast with AWS or really any of the clouds is your security groups and then your tags. Because when you sort of decided, you sat down and you wrote like a tags document. You said all of our servers are going to have a security classification tag, and all of our servers are going to have a operating system tag, and all of our servers are going to have. Your engineers followed that for about, right? And in Terraform, tags to write to everything, and they're going to always be written. I've got an application tag, an environment tag, managed by Terraform tag, a name tag, a project tab. That's something AWS does on its own.
So you said it's an auto-scaling group, but they're all already running. So is your minimum, you said you created 10, is that your minimum? And if you're going to auto-scale to something bigger than that, stop them, or is it not greater than that?
If you go back to the console output, you can scroll up to the actual command that was issued. You'll see we pass a lot of these on the command line to Terraform, and then some of them are actually read out of console. So those counts that you're talking about, unfortunately, have to be on the command line because today there's actually a known. I don't know if it's a bug.
Yeah. No, it was a bug in my opinion. So it's sort of a, in my opinion, a birth problem of Terraform, right? Which is when you see the counts on an instance, right? I'm supposed to create 5 servers, right? It's a count of servers. It's actually not. What happens when Terraform runs the plan is it creates 5 instances of that object. The problem with setting the counts from a data source or a variable was what happened. The counts were already interpolated.
The initial version of Terraform, you didn't even have count. You just repeated yourself 5 times.
Yeah.
And it was just a quick way for them to solve. I think
Where's your command, Jim?
though was
So
the
right there.
relationship between auto-scaling groups and the count. You want to start an auto-scaling group with its minimum number of servers. You
Yep.
don't want it to be below the
Well, there's actually 3 metrics, right? Auto-scaling group has a minimum, a maximum, and a want. And so what Terraform actually does is it's spinning up to your want. You could have set a min to 1, a max to 30, and a want to 10. It's gonna turn up 10 servers. Now I could actually show you in.
You'll see on the end of that line right there where the dash bar ASG min. That's where we're passing those values into Terraform.
That's an important question though. So hang on, let me show you something.
And there actually will end up with 1 because our auto scaling.
Today.
Yeah. Reduce it down to 1.
So the auto scaling sort of functionality, or what AWS and Terraform does, how we're doing rolling deployments, right? So when you spin up 10, for example, let's say you only want 5. You want 5 servers. Well, for the way we're doing it, we actually have our max and our want set to 10. Create new servers or a new application. It creates 5 more that are brand new, scale down or remove the 5 that are old. It's actually a deployment strategy. If we stand here long enough, yeah. Sorry. Stand here long enough. Come on. Those apps, there's I think 10 of them right now.
They've already started.
Yeah, it's already, see the 3 at the top, it's already terminated 3 of them. I mean, just like normal scaling is, we've told it to create more servers at a certain CPU threshold. We've told it to destroy servers at a certain CPU
What did
threshold.
you use for a metric in this case here to actually do the scale?
CPU,
CPU
yeah,
usage?
in this example. Sort of one of the things that we want to do in the future, we haven't done it yet, but we want to do it in the future, is watch metrics are really sufficient, in my opinion. CPU is not really a good determiner that the server's busy. Memory, neither is, you know, there are some other tools that give a much better indication. For instance, New Relic, right? So we actually want to, in the future, sort of function or something to tie the sort of the New Relic metrics into our auto scaling groups, because CPU really just does not work. Now, in this case, what you're seeing here is that I think it's set to, if the CPU is below 20%, start killing servers.
Say it's CPU individual?
Individual.
Summation?
Yeah, individual.
So, can we use load balancer as a threshold? Like you can mention, like the traffic has reached this level.
I think you can. Yeah, I think you can.
It's or something.
Yeah, I think you can.
So one more thing, you said the oldest instance will be deleted first.
Uh-huh.
Is that based on that level rule which is
It is. So in an AWS auto scaling group, you can choose. There are these things called, what are they called? Called load strategy, actually. Okay, we'll go look. That one moved. No, those are the scale policies. In here. Oh, you know what? It's not. It's under load configuration or launch configuration. I don't know where it is, but you can actually set it now. Is, in my opinion, the best thing to use, because it's there are different choices. You can tell it to kill the oldest one first, the oldest launch configuration first. You could tell it to kill the newest one first. But and if you go actually read on AWS's auto scaling, these policies are very detailed. Default is the most economical. I think it'll kill the oldest one first, but not if that server is created within a few many minutes. Or
Search on ELB strategy.
I mean, one of the things that AWS, for example, and I don't know about the other ones really good at, is the stuff's pretty well documented. Like,
Yeah, it's called, what he's talking about is called the ELB strategy.
no, it's in the auto scaling group, I think. Yeah, 2 different things. Maybe I'm not seeing it. Oh, there it is. Termination policies. Yeah, so default's there, but there's a whole bunch of other choices down here. Oldest instance, oldest launch configuration, newest instance, closest to the next instance hour. So obviously you pay per hour.
Yeah.
So you could, in this case, kill the ones that are closest to financially effective.
Well, it's an auto scaling group, so you may, if you choose to kill the one that they're running it, if you're using a spot instance and you don't pay for that hour, you might save some money because you could run it 59 minutes and get it for free.
True. But if you look up the termination policies, they say that the default is sort of the compromise between and the instance hour financial calculation. Let's see, what else do we have? It's all right. So, can I terminate stuff? Destroy stuff? Okay, in my opinion, destroy is the coolest thing. All right, so we've actually just built destroy as a sort of, we've just built destroy as sort of a sub-function of this application. Wouldn't that be all? Oh, actually, hang on. No. I didn't prove this.
Oh, he doesn't even know about that.
You did what?
Server.
Yeah, I didn't
Oh, that's right,
You guys are good at just fooled us.
Yeah, that's true.
Where's the app?
Yeah. Oh, come on. No, it's not. This is.
We had to delay a little bit so that the DNS propagated.
Yeah, right. That was the
I
cookies
totally-
in the oven. Are you guys using CloudFront?
No.
Not anymore.
There's our test application. That's my dog.
That's the app that just came up on 10 servers.
Yeah, that's the app that just came up on Twitter. I like that because, in my opinion, that bubble is kind of like immutability, and he's jumping for it. Yeah. For the dog.
That felt well.
I know.
You gotta work on that.
I told you I wasn't a salesman or a presenter. Oh, that's the wrong one. We'll tell it demo and destroy. Perf demo 1.1 destroy. So destroy is actually just a command in Terraform. There's plan, apply, and destroy. So we've told it we want to destroy, and it's going to destroy.
So what it basically does is it goes and reads the state file and gets all the information, and then it just starts deleting.
And it's
So just like you said, they use plan, so you avoid.
oh yeah.
Yeah, right. So I didn't see any like, do you really want to destroy?
So,
Like,
yeah,
any confirmation of what
there is a
yes.
confirmation.
Okay.
I pass it a -y
Yeah.
because I wanted to just, because it'll fail if I don't.
Okay, I guess, yeah, just checking.
We've also talked about putting, like, I don't know if you saw when he created like the environment, there was a checkbox for protected, which would kind of add another layer of, you can't just go in there and click on that and delete it without actually doing something.
Yeah,
with it.
you can actually in Terraform essentially tag something as protect from destruction. What it really does is if you try and run that code, it's going to say this instance or this object was created from or protected from destruction. So you'd have to go and edit your Terraform code without that command, and then you destroy that. It's going to take probably longer to destroy than it did to build.
Do you have the link to console?
You want to look at console?
So can you set the permissions in Terraform, or how does that work with IAM? So like, can you stop and what prohibit termination of instances or?
With that protection you can.
Yeah, with that protection you can.
But it's not like there's no like you log into Terraform or anything like that. I mean,
Is Terraform essentially?
No, they
running
created a destroy job in Jenkins with all these lines of code in it. It wasn't just like there was a magic destroy button. Hit that magic destroy button. They had to do a lot of work to get destroy to work. It wasn't just there.
so
Essentially,
essentially,
whatever you write in Terraform or Jenkins, it's going to do.
we're telling you.
No, so destroy is actually in Terraform, what it's going to do is it's going to read the state file. Today exists.
Right.
And in a few minutes, it's not going to.
Yeah.
It is a powerful command, no doubt.
So a lot of it depends on
what's planned in Terraform.
Yeah, only what's planned.
Were you asking, like, if there's any kind of, like, authentication around that? Like, the
I'm
ability to
asking
say,
if
hey,
you
you're
can
not
create-
allowed to destroy stuff?
Create something that you can then cannot terminate. Can you
I-
create an EC2 instance that you don't have the rights, can't terminate?
Well, so you can by putting the protection from destruction on that instance inside of Terraform. So the Terraform we're using is essentially the community version, right? It's actually not like a commercial version of Terraform, but it's sort of a commercial management version of Terraform. What it does is you still write your Terraform on an open, on the community Terraform version, but then you syndicate it with Terraform Enterprise, and they suck it up to their cloud. Wrap ACLs and stuff around things in the enterprise version.
The bottom line is your state file is kind of the key. If you can protect your state file and make that inaccessible to somebody that doesn't have permission, the state file, they can't run and destroy against that. Because really that's all that destroy command is doing, is just saying, you should go destroy it. So you can protect that on S3, you could protect it in, Vault, console, I think can.
Yeah, that's true. I mean, even in the basic example, if your Terraform state was literally on the Terraform server, you could just say only this user has access to the file. And then when you ran Terraform destroy, if it can't read the state, it's not going to do anything.
Because it will error out if it can't read the state. Like, it looks for the default like TF state file.
What do you want to look at in
So environments, and this is kind of the where things get stored. When Chris ran that job, he basically deleted off the. Is that other environment got the application still in it? I don't know if it did or not.
Oh yeah.
There. Environments. That you would
Nope,
still
it doesn't either.
But anyways, earlier there'd been a folder in there called demo, and it would have had some of that information that Chris populated, which had the base APIs and things like that. What version of the app we wanted and that kind of stuff. So Terraform actually will go out and retrieve those values and use them as variables in the actual supply.
So application environment, 10 server, actually probably not 10 servers, like 6 servers, SQL servers, Couchbase servers, Elasticsearch servers, all the security groups, all that destroyed in 27 seconds. Now let's destroy an environment now.
So we kind of use console a little bit. I mean, it's a key value store, and we kind of use it as kind of like a interim database for our stuff. It's probably not the most ideal solution, but trying to accomplish here. Our plan is, or my plan is to kind of have a some kind of website where, say, a QA manager can come in and say, I need a version A or version 1 of this application, version B of this application, and version C of this application in QA, and hit apply, and that will kick off these jobs to build that environment so they can customize it any way they want.
Yeah, my desire is actually to get past this and get to no ops. Developer says, I need to build an environment and server instances for this build. And when he kicks off, the website, for example, that Jim's talking about, fires up, does, security practice tests against the code before it even creates an environment. Against the code before it creates an environment. Does a functional test group once it creates the environment. Does vulnerability testing after it creates the environment, right? Tech ops engineers, the server admins and stuff, I mean, we can save them to do better work, to go out and research and develop new things, to go play with the new versions of the operating systems. This stuff is not what they need to do. So I've told it I want to destroy perf. It's in US West 1 and where did you wrong?
Check the command.
Oh, no.
Oh, you want to destroy.
Oh, you're right. Good point.
It actually
It would have done nothing.
It actually
Yeah.
wouldn't have built it again because the state file, it will
Yeah.
point to the state file and it'll say, oh, it will actually build.
Perf already is.
It would have done nothing except for make me look funny.
Yeah. And that'd be it.
Yeah, thank you.
Should let you know.
Yeah, you should have. So this is probably going to get an error because Terraform currently has a bug, which is we didn't talk about that, but in the environment stack, we're creating some serverless Lambda functions. For instance, Couchbase. Couchbase, we're building the servers, we're joining them to a cluster, but sort of the finalized to know all the servers are joined and create buckets, we're using a Lambda function for that. And Terraform has a bug, which is when you destroy whatever the Lambda function's in. You can use Lambda a number of ways, but one of the ways to use Lambda is with something called VPC config. Interface and INI into your VPC. Terraform's not destroying the INI correctly. So this is probably going to get to almost the end, and then it's going to timeout. I'll show you if we get to that point, just so you can see nothing's perfect.
So I guess we'll go over a few minutes, but I think there was a question earlier that we could just have some open discussion about. And that's that in terms of going from where you currently are to something. So by show of hands, who would say they have like a DevOps pipeline that is something like this? Good, Jack, okay. Okay. What are you guys using? Just give us a brief description of it.
Like a business release process. We're using for the chef deployments actually.
Mm-hmm.
So basically what we do is like we're going to have our Git as our repos. And we use them mainly for building the WAR applications and like WAR files. And deploy them at the same time using the pipelines. And one until the dev environment, not for the prod, but for the dev, we use the Eclipse and run every time the checking is done on the master branches.
And it's running tests also?
Yeah.
And it's all driven by Jenkins, probably, right? Okay, so Jenkins, Chef, JUnit tests, right? And then that gets everything to dev. And then you guys are doing some other deployment process to go past that, right?
Yeah, like once it's the file is ready, we usually deploy for the QA and other environments, we go for the deploy jobs again. Deploy jobs for the QA environment, for the higher like perf and
right. So is there any automation around your actual server infrastructure? So you have a,
only this is
okay, cool. So there's some distinctions there, right? Pipelining your infrastructure, your whole infrastructure, and then deployment inside of that. I would agree most people are kind of like happy to get to this level where their pipeline is at least automated, right? Anyone, Jack, what do you guys?
We have these, which we build infrastructure on AWS, and we use pretty much Packers and Terraform to build our infrastructure.
You guys are doing something similar.
Very similar, very similar. Then we have VHE, VMware. So we see this Packer, but we are not using Terraform. We are using a Python script.
You asked kind of about how we got here, kind of our journey and what we looked at. We set very early as a goal was immutable, right? So we kind of worked through what Chef could do, for example, right? And I mean, it's an awesome tool. Like, for example, inside of our Packer build, we're using PowerShell, right? However, I mean, as far as configuring that server, Chef would be a good thing to do. However, we sort of decided that for the minute that it was alive, a little bit of a waste. So even though it would give us sort of efficiencies in that part of the code, it wouldn't be like a long-standing server that just runs Chef over and over and over again. It would run Chef run, you know.
So here's where Chris and I kind of disagree a little bit, because I think Chef absolutely could work in this scenario. You could build your entire infrastructure, you know, using Chef management, your actual application install. I mean, don't think this is like the end all be
Oh, yeah, yeah.
thing, right? Chef is a
Yeah.
very viable solution. In fact, that first video that Chris put up, I did 3 versions of it.
Yeah.
Had totally baked in application.
Yeah.
And there was still a problem up until, and we actually still have a problem with different environment configurations. So how many of you guys are doing Windows and stuff, but I'm sure you have different connection streams, you have different, IP addresses where your servers live and things like that. And that's why we said now to be our DNS and service discovery. And we're just going to register all of our services with consoles. So we can use the same DNS name basically for in each of these environments. So as SQL 1 dot whatever, SQL or
It's happening, by the way.
environment or
It's about to time out because of the Lambda function.
QA has SQL 1 dot whatever, and that kind of stuff. So we don't ever change. Like we basically have the same exact configuration going into environment, and console is going to then become the differentiator between is this dev, is this QA, is this production.
I love Chef, right? Don't get me wrong, right? I've just seen a lot of implementations where they've used Chef long past where I think they should have, right? Like I've seen provisioning management, launching servers, launching VPCs, all done from Chef. But essentially what they did was they created a server and then they told that server, your recipe is all of these commands, right? And even if I didn't want immutable, right? If I wanted traditional, I would use Terraform to create the servers. Servers would then do Chef run to get their configuration. I was trying to fix my problem here.
Anybody else have a pipeline that they want to describe?
So that network interface up there is the one that Terraform's not correctly deleting out of the Lambda function. So I'm just, and then when I go back and run the Terraform function again, it'll work. It's not perfect by any means, but it's as close as I've ever been.
We did like in your environment where you already had. Are you creating the whole node with Chef? OS up?
Yeah, not from the OS up because we are actually using our data center.
Yeah, we don't have it.
Okay.
Yeah, we don't have it.
Yeah, a VM.
It's what, rebuild or something? It's an add-on, I think, isn't it? Yeah.
Okay.
He makes me do things the hard way.
Okay. Cool.
Is that all right? Yeah. Yeah, the one thing that I actually found is Terraform moves pretty fast. So like, I don't know if you go out and look at the Terraform forum, there's a bunch of bugs in there. I'm not contributing to it by any means because that's what Terraform's written in. That's what Packer's written into. But they're pretty aggressive at fixing things. So for example, live, there was a Terraform version like the next day. The count bug we talked about earlier has been around for a long time because it was very deep in their code. Hopefully their Lambda thing will be fixed soon. So there we go. It destroyed this time. And we can go look. And the VPC. We're back to our 2 VPCs. We got, so that if you remember, it's called perf. So it's gone. Used to wire that switch and put up that firewall and put up that rack. It's all gone. Anyway, cool.
So, y'all doing all this on AWS, like, AWS has CloudFormation. That's a very similar tool.
Yep.
Obviously, there's advantages and disadvantages to one over the other. What were some of the reasons y'all decided to choose?
I got it. So there's really 2. So the first is only. It's not protocol or platform agnostic. We were told to be platform agnostic. Our CTO said we don't want. So even even outside of this DevOps project, our CTO doesn't want us using anything in Amazon that essentially
Vendor lock.
can't be used somewhere else. He calls it vendor lock. DynamoDB, we're not using Kinesis, we're not using whatever their queuing service is. If we can't move it somewhere else, we're not. So, like for instance, we'll use SQL on RDS because SQL, DynamoDB, and CloudFormation. CloudFormation's awesome. It's truthfully very similar to Terraform. I think the only benefit, in my opinion, of Terraform or CloudFormation is just the list of providers.
That's an answer.
Yeah, so Terraform has providers for, I think it's hundreds of things. There's console provider, Docker provider, Chef provider, AWS provider. Hell, I don't know what most of these things are, but a VMware provider. And providers are what's added probably the most frequently to their project. Essentially comes out every release. I've got a guy back at the office. One of the providers here is GitHub. Completely infrastructure as code our GitHub configuration. So we have a list of users, for example, out of Active Directory. He wants GitHub to be on autopilot. Kubernetes. It can actually create your New Relic, I think, monitors and RabbitMQ.
So roughly, you could use your dimming in Azure, for example. Somebody
Yes.
says, I want to do that in Azure.
I mean, we'd have to. It would take effort. We'd have to go through and rewrite sort of our Terraform configuration with Azure. But going back to sort of how we got here. So he started 6 months, right? September, October. So a little over 6 months. Before then, I had played around with Terraform a little bit, right? But we really didn't start until he got there. And now he's full time, so 6 to 8 months. Give it maybe, how much do you think I give it? An hour a day? About an hour a day. So, I mean, I can't say it's not a considerable amount of effort, but it's really not as hard as it looks. The learning curve's pretty low. Like, for instance, sort of a kudos to the entire DevOps world. For instance, Chef, right? What is it? Get started with Chef. Learn Chef, right? And it pretty much the thing you need to do to sort of bootstrap to get working. Terraform's got exactly the same thing. It says create a server. Now do this. I mean, it's pretty easy to learn. I mean, I'm not a smart man.
I mean, and you can learn. You can use it with Vagrant. I mean, so you don't even have. You don't have AWS. You can use it with Azure. You can use it with AWS. Just be careful when you start messing around with VPCs and some of the bigger things. But like just deploying instances. I mean, really simple.
Yeah, it's really not tough. And going back to one of the first things I talked about, nothing else I would have done my security groups in Terraform.
And there is a command in Terraform that will actually go look at your AWS environment and build a state file.
Yeah.
So if you have an existing environment that you.
However, that's dangerous.
I agree, it's dangerous. Try it and do it in dev first.
So, well, hang on. Since you brought it up, I'll explain to you. Import and what?
This way.
Hey, I'm in there.
Okay.
I see myself. So there's a Terraform import, and what it does is it goes and it looks at your environment based on your provisioners. It will put those in state. It's not going to create the configuration files for that. There's a roadmap to like automatically create the config based on what it sees. However, so right now what it will do is it will import state. So if you have existing servers, you can tell it your AWS environment, it will go through and it'll make state for each of the servers. Follow up and write the config that would have made those Otherwise, the next time you apply, it's going to delete them. They're going to be in state, but they're not going to be in config, and it'll remove them. So what they
There's
do.
a really good way to fix the corrupted state file that you mentioned earlier.
Yeah. Yeah. Well, when
Kill it and import.
actually happened to us. We've never had a corrupted state file, but I mean, everyone's lost a file or a server or SAN or something before.
But we keep our state files in S3, and we also version that S3 bucket. So
Well, yeah, that's true.
you know, if you read on Terraform's website, they talk about remote state and how to kind of manage that. There's some things you have to be careful of when two people are trying to do time on the same state file. You can get contention for who's going to get to update it and that kind of stuff. But they list kind of the best practice for how to protect those files.
Yep. And we're way over. If there's any other
Right.
questions, I'm still here.
Yeah, so we'll just testing.